Hi, so remember this video? This was from lesson 9-1 where you learned how to solve a quadratic by completing the square. Professor Trevino went over this one with you, and I just wanted to start this lesson with this problem, and I'll probably will jump back and forth because this is exactly what I'm going to do to this problem. What? This problem doesn't have any numbers in it. I know. We're going to do it with nothing but letters. And it's going to get kind of hairy. Let me give you a preview of what. Uh-oh, that's not the right one. Here's the preview. So this is what it's going to look like as we go through it and do it. Ooh, yuck. But here's the good news. Be scared. It's okay. This is very scary. Here's the good news. One, I'm not going to ask you to do this by yourself. I'm not going to ask you to derive the quadratic formula. I'm not going to ask you to do that. What I am going to ask you to do, though, is to reproduce this in a lesson that looks something like this. So I'm going to give you all of the steps, and then you have to put what it looks like algebraically. You know, here I describe what we're doing in words, and over here you have to put what that looks like in symbols. So that's what you have to do. All right. So I'm not asking you to generate this all by yourself, but I am asking you to be able to read this. Okay. Divide the general form of a quadratic equation by a, subtract the constant, take half of the linear term, factor the trinomial. You see all of these vocab words? If you don't know these vocab words, then you're not going to be able to figure out where to put what. And you can't trust anything that I've done right here because I was not even looking at those. I was just, moving stuff around to show you that this is what you're going to have to do. So back to this. I am going to go through this. This is copied from Professor Trevino's YouTube video right here. This is copied and pasted, but in order for these steps right here, in order for the process to match what it says on this right here, we have to do these first steps right here out of order. So instead of doing step one, then step two, we have to do step two, then step one. It's okay. It's not going to matter. And I proved that to you by taking this problem that Professor Trevino worked in that other problem. She worked this problem, and what she did, let's go back and see real quick what she did. She did step one right here. She said, do the opposite to move the constant. So she did the opposite of -5. She said +5 +5 to both sides of the equation. Then step two, she said the value of our a, which is the number in the front right here, must equal 1. So you have to divide by whatever the coefficient is. So she divided this by 4, she divided this by 4, she divided this by 4. And this is what she ended up with. Okay, I'm going to show you that if you work this problem and you do step number 2 first and then step number 1, if you do step number 2 first, divide everything by 4, then do the opposite with your constant. The opposite of -5/4 is to add 5/4. You end up with x squared plus 4x equals 5/4, which is exactly what she ended up with right here. X squared plus 4x equals 5/4. So my point in showing you that is to let you know that even though I'm going to switch the order and do step 2 and then step 1, it's not going to change anything because those two steps end up being the same thing. And you guys should be okay with that by now because we solve problems, differently all the time and come up with the same answer. So I'm going to divide everything by a. So I'm going to divide this one by a, I'm going to divide this one by a, I'm going to divide this one by a, and I'm even going to divide 0 by a. So when you say any number divided by itself, a divided by a. Now I'm going to simplify, okay? So this is, I divided by the coefficient, and now I'm going to simplify. So I'll even label it. This is step 2. And what did I do? I'm dividing by the coefficient. So I'm going to do x squared, because a divided by a reduces to 1, plus, can I divide b divided by a? Nope. So I'm just going to leave it. B over a, x plus c over a equal to 0. Now I'm going to do step 1. And step 1 says do the opposite to the constant. This is still a constant. It doesn't have an x. So it's an uglier constant because it's in the form of a fraction, but it's still a constant. So I'm going to do the opposite of plus c over a. What's the opposite of positive c over a? Minus c over a. Okay, and then that's going to give me x squared plus b over ax equals, why do I have an equal sign right there? Because those two add to 0, equals 0 minus c over a is a negative c over a. All right, now it says that I have to take half of the coefficient. So I've got to take half of the coefficient. Take half. How do you take half? You take half by multiplying. That means multiply by a half. That's how I'm going to take half of it. So if I take b over a and I multiply it by 1/2, how do you multiply fractions? Top times top, bottom times bottom. You get b times 1, which is b, and a times 2, which is 2a. So it says take half the coefficient of the bx term, there's half, and square it. So I'm going to take half of this term right here, and now I'm going to square it. Okay? So, so this is step 3 right here. This is step 3. I took half of the term to square it. Now step 4 says add that to both sides of the equation. So this is step 4. So add that now to both sides of the equation. X squared plus b over a x. I'm going to add b over 2a squared equals negative c over a plus b over 2a squared. So, I just finished step 4. You add the number from step 3 to both sides of the equation. Step number 5, I altered what she wrote just a little bit. She said, rewrite the left side as a perfect square trinomial. I wanted to add in factored form because as we were working this problem over here, remember I added, I took half of this middle term, half of 4 is 2, and I squared it. So 4 is what went right here and what went right here. This is a perfect square trinomial. Okay, so that perfect square trinomial needs to be written in factored form. This is factored form right here. So that's the complete step number 5, is to write it in its factored form. And remember, this number right here is always the same as this number. When we take half of b, whatever half of b is, that's what goes right there. So that's where I am over here. This needs to be in factored form. And factored form means it's going to look like that. Okay, so, and then I'm not doing anything to this side because step number 5 just says rewrite the left side. So this side's going to stay exactly like this for right now. It looks kind of ugly, but that's okay. It's going to stay. Now, factored form of this shouldn't be hard. We just put the x. We put the plus sign because that's a plus sign. So this is going to be a plus sign. And what goes right here? Half of that. We got half of that right there. So we're going to put b over 2a right there. And that's all there should be to be rewriting that in factored form. It should be that easy. So over here, we took half of that number is 2, stick the 2 right there. That's what you're going to do. If that number was a 10, you would put a 5 right there. If that number was a 20, you would put a 10 right there. So whatever that number is, take half of it. That's what goes right there. So rewriting this in factored form is just that easy. Now step number 6 says that we've got to finish solving this one. So since we're solving this one and we have no numbers, then it's going to be several steps in addition to that. So this video is already quite long, so I'm going to stop this video right here and do a part 2.